Now let's look at a 3-input Karnaugh map, and specifically we want to pay attention to our groups. And a fancy name for our groups that we use with Karnaugh map terminology is implicants. So implicants are just groups of ones. So I've given us a truth table to work with here. This is kind of the most common thing that you're going to work with, is a truth table going to a Karnaugh map. And let's draw out our K-map. So we've got 3 variables, 2 to the 3, right? 2 to the 3 equals 8. So that means we've got 8 rows. So that means we should also have 8 cells in our K-map. So here's how a 3-input K-map looks like. Oop, maybe I should do a little bit straighter of a line there. There we are. There we are. And then we cut it into 8 cells. Now we can draw our little line here to divide our axes. And as I said before, we always start with our first letter in our truth table, so A and B. So here we've got enough room to have A and B on this axis, and then here is C. And now we want to put our numbers on here. So the first thing that we can have is A and B are both zeros. So that's 0, 0. And then we want to change one of these variables, so we'll start with B, kind of like we're counting in binary, 0, 1. And then we want to change from this row to this row, we want to change another variable. If I were to count regularly in binary, this would change to 1, 0, and that means 2 variables would change. And we don't want to do that because we want to just find one variable changing per row or per column. So actually what we're going to do is we're just going to write 1, 1. And that means that only one variable changed from here to here. So one variable changes, one variable changes. And then our next step, we want to only have one variable changed. And the only combination that we haven't used yet is 1, 0. So we'll put that there. So as we go about this, only one variable changes at a time. And then for C, of course, we've just got 0 and 1. And now we can go about filling in this Karnaugh map. So we kind of treat each one of these cells as a question or kind of a lookup problem. So for this cell, we say A is a 0, B is a 0, and C is a 0. Well, we look at our row in our truth table where A is a 0, B is a 0, and C is a 0, and we see that our output is 0. Now we can go to this next one here. A is a 0, B is a 0, and C is a 1. Well, that's our next row, and that's a 0. Now, A is a 0, B is a 1, and C is a 0. That's this row. And it looks like our value is a 1. A is a 0, B is a 1, C is a 1. Looks like that's this guy right here, and our output's a 1 for that cell. Now we're going to skip a little bit here, because the way we numbered this, we've got A's a 1 and B's a 1. So that's A's a 1, B's a 1, and C is a 0. So that's this row right here. So that's a 1 there. Then A's a 1, B's a 1, and C's a 1. That's this bottom row, right? A, B, and C are all 1. So you notice that we kind of did these 4 here, then we did these 4, and so that's going to leave us with these last 2 here. So now we have A's a 1, B's a 0, and C's a 0. So 1, 0, 0. So that means we have a 1 there. And then our very last one is A's a 1, B's a 0, C is a 1. And so we've got it right there. That's a 0. So that's one way to do it. We could also go the other way where we could say, all right, I've got this row, A, B, and C are all zeros. What cell is that? And so you could just kind of work your way down this. Whatever works for you. Actually, I prefer to do it the way I just said, where we work from the truth table to the K-map and not vice versa. Either way, now it's filled out, and we can start selecting our groups or implicants. And one of the rules that I said is we want our implicants to be nice rectangle shapes, and we also want the number of ones inside that group to be a power of 2. So that's 0, 1, 2, 4, 8, 16. So if it has 3 ones in it, that means it's not a properly sized group, and we need to reevaluate. The other thing that our groups need to do is they need to be as big as possible. So let me show you an example here of something that is not fully right. If I were to say, oh yeah, right here's a group of ones. Here's another group of ones. And here's a group of ones. And remember, I did say that it is okay if they intersect. Whatever it takes to make our groups get as big as possible. So here we've got them intersecting, but that's totally fine. One of the problems, though, is that this implicant here could be bigger, right? This could be a group of 4. All we have to do to realize that is to look at its neighbors and see that this could kind of grow into this group of 4 here. So let's what I just did was an example of something incorrect. Here is an example of a correctly sized implicant. And it's also true that I could say, here's an implicant, but this implicant, or this group, could grow to be bigger. We never worry about the implicants intersecting. That's not a big issue at all. So we kind of look at this guess here and say, here's an implicant, and we say, hey, this could actually grow a little bit bigger and still follow our rule of being a power of 2. So let's do that. And then as our last step, we can kind of just evaluate and say, is it possible that any of these could get any bigger? And we see that this kind of has nowhere to grow. We say that, oh, this maybe could grow out this way, but that would be 3 ones in that implicant, and it's not a power of 2, so we can't do that. And we also can't do any weird shape like just circle all of them. That's not going to get you anywhere. So we can actually conclude that this is all grouped up properly. So now what we can do is write our expression here. So let's first look at this implicant here. And remember, we want to factor out the variable that's staying common for this group. So what's staying common in this group? Well, let's look at it. We see that A is a 0 here, and A is a 1 there, so it's not A. We find that B is a 1 here, and B is also a 1 here. So that means B is constant in this group, so this would get factored out. And we see that C changes from a 0 to a 1, right? We're just looking with regards to this group, right? We're not considering any of this extra stuff. We're just saying that this group has this row and this row, and so that means C is a 0 for this row and C is a 1 for this row. So that means it changes. So what we factor out of this is B. Now let's look at this smaller implicant. Let's see what stays the same. Well, we have A is a 1 here and a 1 here. Just to remind you, right, this leftmost variable is A, and the rightmost variable is b. That's kind of the way our scheme works there. So we said here a stays the same. So let's write down a. Looks like b changes. B is a 1 here. B is a 0 here. So we can't put b in this term. It looks like c is a constant 0 for both of these. And so since it's a 0, we actually prime it, right? So c prime. So this is a and c prime. We're anding together the variables that we're factoring out. So we've got the terms for each one of these implicants. So that means our final function is just these terms ORed together. So x equals b or a c not. Once again, there's a lot of subtleties in Karnaugh maps, and the best way to get good at it is to just practice and do a lot of them.